Okay, let's talk about converting with the mole. So we talked about today in class moles. So let's look at this chart together. So we have moles in the middle. That's our big converting unit. So if we start with the number of particles and want to get liters, remember, because we're not worried about molarity right now, we can use moles. So we use 6.02 times 10 to the 23rd particles per mole to get to moles, and then we can use moles and molar volume to get to liters in the end. So if we start with liters and want to get to mass, we can start with liters, convert to moles. Once we've converted to moles, we convert to grams by using molar mass. And then finally, our last conversion, we can start with mass in grams, use molar mass to convert to moles. Once we get to moles, we use the relationship between particles and moles to get to the number of particles. Remember, the number of particles can be atoms, molecules, or formula units. Now, I know today we talked about some longer ways with more steps, just because I wanted you guys to see the process, but I'm going to go through about 10 examples with you guys, and I'll show you some shorter hand ways to do it now that we've talked all about it. Let's first start with one of each example. So let's say we start with 4.78 times 10 to the 25th atoms of, let's do phosphorus. I'll write it out. Phosphorus. Oh, let's move this. Phosphorus. Okay, and we want to know how many grams of phosphorus do we have. Okay, so we can use Avogadro's number. We have particles, we need to get to moles, and then we need to get to grams, because there is no direct relationship between atoms and grams. So let's start. Atoms of phosphorus. Remember, that's what was given, so we're going to put that over 1. And let's convert. Alright, so we need number of atoms to convert to moles. So we've got 6.02 times 10 to the 23rd atoms of phosphorus. We want to label everything. And this is per 1 mole of phosphorus. Alright, so let's check our units. We got rid of atoms. Now we have moles. Let's get rid of moles. So we're going to put moles on the bottom. So 1 mole of phosphorus. And that's when we look at our periodic table and look for the atomic mass. Now the atomic mass is the same as the molar mass. So we look at phosphorus and it's about, mine says 30.97, but about 31 grams per 1 mole. So grams of phosphorus. Okay. So we get out our calculators. Let's see. Do the math. Oh. Okay. So we've got 3 significant figures. So I got 2,460 grams of phosphorus. So that's how we'd go from atoms to grams. So let's do another one. Let's do a simple mole to gram conversion. So let's say we have 7.25 moles of sodium. And we want to know how many grams we have. So we're going to start with what's written, put it over 1, and let's convert. So we're just going grams to moles, so we just need to find the molar mass. So We want to cancel moles. 1 mole. The molar mass of sodium is 22.99 or 23 grams sodium. Want to make sure we're labeling everything. Alright, so when we do the math, I got 100, we have 3 sig figs, so 167 grams of sodium. Alright, so that's how we go from grams, or from moles to grams. Okay, so let's go from liters to moles. So we need to have a gas, so let's do 1.95 liters of carbon dioxide, and we want to know how many grams this would be. So grams is our end result. So we're going to state what's given to us. We're going to put it over 1. Now we want to cancel these liters. And remember, we have a molar volume conversion factor that every gas, for every 22.4 liters of gas, we have 1 mole. So if we want to cancel liters, we got to put 22.4 liters on the bottom per 1 mole carbon dioxide on the top. We've canceled out the liters. Now we're in moles. So now that we've got it in moles, we can use molar mass. So we've got 1 mole of carbon dioxide, and we need to find the molar mass of carbon dioxide. So remember, we're just going to take all these elements and add them up. So carbon is 12.01, and there's only 1 of them. Oxygen, 16.00, and there's 2. So when we take 16 times 2 plus 12.01, that's going to give us carbon dioxide's molar mass of 34.01 grams per mole. Okay? Now we've canceled moles. Now we've got grams. So let's do the math. We need 3 significant figures, so I have my answer as 2.96 grams carbon dioxide. I remember we used that molar volume for our conversion, and that's for every gas, not just one gas. Any gas you have, you can use that. Okay. Let's do moles to molecules. So let's say we have 9.72 moles of nickel to oxide. And we want to know how many molecules. So the first thing we need to do is figure out nickel 2 oxide from its charges, what its molecular formula is, or its formula unit. Excuse me. So we've got nickel, which is a transition metal, and so it gave us that it's +2. So that has a +2 charge. Then we have oxygen, which is a -2 charge. Remember, this is 1 for 1, so we really, nickel 2 oxide is just nickel oxide. You know what? Let's do a little more complicated one. Sorry. Just so you guys can see the conversion. Let's do nickel 3. Nickel 3 oxide. So nickel 3 oxide would be +3 -2, and then we're going to switch these. So we'd have 2 nickels, 3 oxygens, and that's our formula. So let's go ahead and figure out the, well, we won't need to, so let's not. Alright, so now we have, what did I say, 9.72 moles of nickel 3, nickel 3 oxide, and we want to get to molecules. So we're going to put that over 1. We have a conversion for moles to any particle. And it's Avogadro. So you can use atoms. Remember, you can use atoms, molecules, or formula units. So since this is an ionic, I know I keep saying molecules. This is ionic, so we need to find formula units. So we're starting off with moles, so it's going to be 1 mole. It's going to be 6.02 times 10 to the 23rd formula units of nickel 3 oxide per 1 mole. So let's do the math. I'm getting, we need 3 significant figures, 5.85 times 10 to the 24th formula units of nickel 3 oxide. Okay? So let's talk about, so those are a couple problems. Let's talk about, let me do this. Let's talk about going from grams of a substance, grams of a molecule, to atoms of an element. Okay, so let's say we have 7.33 grams of sodium chlorate. So if we have sodium chlorate, let's find what our formula unit's going to look like. Sodium plus 1, chlorate minus 1. So we have sodium chlorate. Simple enough. I'll just scroll down. Okay. So we're going to start off with 7.33 grams sodium chlorate. Now I know today in class we talked all about, how many particles are in this molecule. So let's solve for oxygen. So we want to know how many oxygen atoms do we have? So now that you guys understand the concept of there's 3 oxygens in this whole atom, it's all this many of Avogadro's number. Let's do a simpler conversion. How many grams of oxygen do we have in grams of sodium chlorate? So let's first solve for the molar mass of sodium chlorate. Sodium in my periodic table is 22.99. Chlorine is 35.45. Oxygen, 16.00. We have 3 of them. So doing that math, I get sodium chloride's molar mass, or sodium chloride, the mass of sodium chloride, 0.44 grams. And this is of sodium chloride. Alright, how many grams of oxygen are going to make that up? That's simple. 16 times 3. We've got 48.00 grams of oxygen. Whoops. We don't need to put that. Grams of oxygen. And that many grams of sodium chloride. So we've got grams of sodium chloride. Now we've got grams of oxygen. How are we going to solve for atoms? Let's convert that grams to moles. we've got 16 grams of oxygen and 1 mole of oxygen. So we've crossed out grams of oxygen. Now we're left with moles of oxygen. We want to get to atoms. 1 mole of oxygen equals 6.02 times 10 to the 23rd atoms. We're getting to atoms of oxygen. I know it kind of got cut off. Alright, so we canceled out moles. Now we're left with atoms, so now we just have to do the math. So, 7.33 times 48 Okay, so now we're on atoms of oxygen. So once we do the math, sorry, I was just talking to teacher. Whoops, sorry. Okay, once we do the math, we got 3 significant figures, atoms of oxygen. Okay. Now I know we talked about in class, when we think about this, like extend this down, when we think about this, for every gram, let me write this in red. So for every gram of sodium chloride, actually I'm going to write, or for sodium chlorate, sorry. So for every gram of sodium chlorate we have, because I wanted you guys to think about this, we've got whatever grams per 1 mole. Well, in 1 mole, we have 6.02 times 10 to the 23rd molecules of sodium chlorate. And for every 1 molecule of sodium chlorate, we have 3 atoms of oxygen. And you could also solve it like that too. You can either have the atoms to molecule ratio, or you can have the grams to gram ratio. It doesn't matter. Whatever way is easier for you to figure it out. Alright, so let's do another one. Let's do, I know there's one from your sheet. Yes, let's do the one with carbon dioxide, or hydrogen peroxide. So, we have 0.16 moles of hydrogen peroxide, and we want to get to grams of oxygen as well. So we can either, if you want to think about, you know, how many atoms are in this amount of molecules of hydrogen peroxide, or if you just want to do the grams ratio, whichever works now that you guys understand. So, I'm just going to do the gram ratio. So, per 1 mole of hydrogen peroxide, there are about, what would that be, 34 grams? 34.02 grams. And then we think, okay, for every 34.2 grams of hydrogen peroxide, there's 32 grams of oxygen. And let's go ahead and solve for atoms of oxygen. So, for every one, I'm sorry, for every 16, I guess I gotta get that, 16 grams of oxygen, there's 1 mole. For every 1 mole of oxygen, there's 6.02 times 10 to the 23rd atoms. So now we can do the math. I'm getting 1, 9, we got 366, 3 times 10 to the 23rd atoms of oxygen. Okay, so let's look at the ratios we have right here. This is going to cancel out. Sorry. This is gonna, so you got your moles canceling out, grams, grams of oxygen, moles of oxygen, you're in with atoms, good to go. So I hope this helps you guys with your practice problems, and if you have any questions, feel free to email me, or I'll see you guys on Monday.